back to Science for Newbies. In this episode, we will discuss what is enzyme. So for that, I'll bring you the great professor from Unique Ahmad. We have Dr. Razila and Dr. Sufina. Say hi.
Hi.
Okay, so actually we know what is enzyme. Enzyme actually is a biological catalyst that is made up of protein in molecules which is we have in nature. So biological enzyme is we can produce it by from the living things such as animals, plants, and even microorganisms can produce the enzyme. So this enzyme is actually it can increase the rate of chemical reaction in our body. So they have a lot of important of enzyme which we have. It can control the speed of reaction. It can be a good indicator for disease, which it can detect any disease that occur in our body. So that is the briefing of enzyme. In enzyme, we also study of immobilization of enzyme. So immobilization of enzyme is actually the act of immovable of the enzyme, which the enzyme can only react only in one spot, only everybody, one spot. So we want Dr. Razila explain what are the methods of immobilization that occur in the world or in Malaysia. Can you explain that? Let's go.
Okay, there are three types of methods for enzyme immobilization, which is carrier binding, cross-linking, and entrapment. In carrier binding, we have three types of techniques, which is physical adsorption, ionic bonding, covalent bonding, and in entrapment, we have a lattice type and also microcapsule type. The absorption immobilization of enzymes can be done by following methods, which is static process, dynamic process, reactor loading, and also decomposition. Other method is a cross-linking method, which is this method is based on the formation of covalent bonds between the enzyme molecules by means of multifunctional reagents, leading to the three-dimensional cross-link aggregates. It is used mostly as a means of stabilizing absorbed enzymes and also for preventing leakage from polyacrylamide gels.
Okay, so before Dr. Razila explain more about another method in immobilization, so we can take a look about this VT about the cross-linking method.
Hi, right now let's have a look at the fifth immobilization method, which is the cross-linking. Cross-linking is the chemical immobilization method that uses a functional agent to bind protein with other protein molecules. Bifunctional reagents can be either hetero-bifunctional reagents that have non-identical reactive groups or mono-bifunctional reagents that have identical reactive groups. Hetero-bifunctional reagents possess two different reactive groups that allow for two-stage conjugations, thus minimize undesirable self-conjugation during process. Homobifunctional reagents have two identical reactive groups and often used in one-step reaction procedures to cross-link between proteins. Glutaraldehyde form intramolecular cross-linkages by covalently linked to the amine groups of lysine or hydroxylysine in the protein molecules. Advantages of forming linkage with lysine are lysine residues located at outer layer, hydrophilic part, of a protein molecule. Thus can easily form linkages and rarely involve in the active sites of enzymes. Advantages of this method are stabilized the absorbed enzyme, simple and fast method, and can use in conjunction with other immobilization methods. The advantages are expensive, low retain power, and can damage the enzyme.
The last method is in entrapment. The enzyme or cells are not directly attached to the support surface but simply trapped inside the polymer matrix. Entrapment is carried out by mixing the biocatalyst into a monomer solution, followed by polymerization initiated by a change in temperature or by a chemical reaction. Polymers like polyacrylamide, collagen, cellulose acetate, calcium alginate or carrageenan, etc. are used as the matrices. Entrapment in gel may cause matrix polymerization or precipitation or coagulation. In entrapment in calcium alginate is mostly the most widely used entrapment for microbials, animals, and also plant enzymes or cells. For example, the reaction between the glucose oxidase with the polyacrylamide using the entrapment gel. The types of entrapment, we have occlusion within a cross-linked gel. In this entrapment method, a highly cross-linked gel is formed as a result of the polymerization, which has a fine wire mesh structure that and can more effectively hold smaller enzyme in its cages. Amount in excess of 1 gram of enzyme per gram of gel or flour may be entrapped. Fiber may be entrapped. And some synthetic polymers such as polyacrylamide, polyvinyl alcohol, etc. and natural polymer starch have been used to immobilize enzymes using this technique. The next is microencapsulation. This entrapment involves the formation of spherical particle called as a microcapsule, in which a liquid or suspension of biocatalyst is enclosed within the semi-permeable polymeric membrane. The advantages of entrapment is loss of enzyme activity upon immobilization is minimized. The advantages of is the enzyme can leak into the surrounding mediums. Another problem is the mass transfer resistance to the substrate and product, and then the substrate cannot diffuse deep into the gel matrix. Okay, that's all for the method of enzyme immobilization.
Okay, so Dr. Razila has explained to you what are the methods of immobilization. So next, this question is, does any one of you know what are the technology that attached in industry for immobilization, either in the world or in Malaysia?
Oh, I know about which technology that we use in our industry now, which is one of it is magnetic hybrid support. And the second one, we have microchannel in microfluidic device. The magnetic hybrid support is actually the application of magnetic support to the enzyme immobilization are mainly based on the magnetic properties of the solid phase that enable a rapid separation in a magnetic field. Moreover, the magnetic supports can be easily stabilized in a fluidized back reactor for continuous operation of enzyme by applying an external magnetic field, and the use of magnetic support can also reduce the cost of the operation. Due to the functionalization of enzyme and its suitable microenvironment, magnetic materials were often abandoned in organic polymer or inorganic silica to form hybrid support. Next is the one that I said before, which is microchannel in the microfluidics device. which is micro-scale device fabrication, microfluidics, and lab-on-chip technology were used firstly for chemical and also biochemical analysis in the chemical and pharmaceutical industry. Integration of flow channel and the reaction chamber in this microanalytical system enable the dramatic acceleration, automation, and also miniaturizations of traditional analytical tools with enhanced performance and dramatically reduce the sample size. More complex microfluidics devices have been developed for bioprocess operation, also enzyme immobilization and catalysis.
So, Dr. Razila just explained to you what is, the technology that attach industry in the world. So, next, I will ask Dr. Sufina, can you explain what are the future technologies that maybe you are doing some research about the immobilization that you can invent in the future?
Okay, now I will be going to explain the future of the immobilization techniques. Okay, nowadays there have many methods of immobilization that have been introduced, but the ideal method for immobilization that not been found yet, since the problem is how to design the performance of immobilization as we wanted, as we desired. So then it's hard to compare between the different method of immobilization, since they have many inconsistency for the enzyme used, such as the source, the purity, the contamination that might occur, and also the condition of the immobilization itself, such as the pH, the additives, and also the time taken. And based on the recommendation that I made is I want to use the magnetic iron oxide particles because it is actually the super paramagnetic nanoparticles that can make the protein, cell, enzyme attached to them, and it also have many advantages due to the small size and large surface area, such as and then it also the versatile agents for the manufacturing excellent matrices for immobilization of free lipase. And the immobilization of the magnetic particles also can prevent the high cost of the production, and also can prevent the long separation process by using the centrifuging process, and also it has better stability towards the pH and heat. The methods of immobilization like physical and chemical adsorption that have been utilized for the immobilization can be combined, and the variations of the methods, such as we can combine the extraction method and the cross-linking method. So when we combine this method, the one method will overcome the other problem from the other method, so it will complete each other. And then I think the recommendation that I will suggest is to increase the surface area of the nanoparticles by using some novel methods that I like example that I explained earlier. And then also we can also make research for the nanoparticles, such as the Janus particles. Janus particles is actually the special nanoparticles that can make the chemical reaction more than 2 chemical reaction occur in one place. I think that's all from me. Thank you.
So, Dr. Razila has mentioned what are the methods of immobilization and attached with industry, and Dr. Sufina just now has mentioned what is the future technology that she will invent it in the future for immobilization technology. So, this is the end of our discussion, everybody. So, I hope you guys enjoy in our reality shows. So, see you guys in the next episode. I'm your host, Dr. Ahmad. See you next time.